Good afternoon, everyone. Warm good afternoon to all of you who have joined this webinar session. Today I'm going to talk about generative AI in the automotive industry. So a bit about myself. Let me introduce myself. My name is Mrinal Subash, and I am a generative AI engineer at CellStrat. I've been working at CellStrat since May of this year. And so I took this opportunity to talk about generative AI and how it's affecting the automotive industry. So, being a huge petrol head, it is a natural inclination for me to talk about this wonderful topic because uh, automobiles have had a drastic in drastic improvement in their innovation and research ever since Henry Ford founded the ever since Henry Ford invented the car, the first prototype of a car in 1904. Since then it has evolved multifold, and now we can see we are coming to a point where we are talking about self-driving cars where we do not need human intervention. So such huge innovations in the automotive industry have propelled me to talk about how, as a generative AI engineer, how I can bring out some of the how I can discuss about some of the innovations that are happening in this field in a broader perspective, and we can narrow down in the due course of this presentation. So let's get started. How do I start?
Top right.
Yeah, sorry. Yeah, okay, sorry for that. Yeah, so just a brief introduction on what generative AI is. So generative AI is basically, it contains the basic fundamentals of algorithms that can be used to create new content in terms of audio, image, text, videos, and simulation. So you all would have heard of prompt engineering, and this is a huge aspect of generative AI where we prompt certain text and we are able to generate new forms of audio, code, images, text, and simulation. So this paves way to a lot of innovation and creativity and saves time for a lot of researchers in the
Can
AI
you
industry.
minimize the Google Meet control? It's overlapping your text.
Sorry, sir.
Can you minimize the Google Meet pop-up box? It's
Yes.
overlapping
Okay.
text. It's
Okay.
not
Okay.
synthetic.
Yeah. Sure. Sure. Uh,
Yeah, go back to PPT.
yeah. You want me to close this, right? This is okay?
No, yeah, no, yeah, now it's okay. Yes.
Okay.
Put it in presentation mode,
Now
please.
it's okay, right?
Put it in present. Yeah, this is good.
Yeah. All right. So that's a bit about generative AI. And so now I'm going to talk about the key areas of generative AI in the automotive sector. So in um, in the automotive sector, we have generative AI's interplay in a lot of these lot of these factors where which involves
Okay, you're gone on mute now. Put
hello, can you hear me
Yeah,
now?
yeah,
So sorry. Can you hear me? Am I
yes,
audible to everyone?
yes,
Okay,
yes,
I'm
yes.
audible, right? Okay, cool. Shall I start? Okay.
yes.
So these are the key areas where generative AI has played a major role in the automotive sector. So one is perception and sensing. You can take the examples of lidar and a lot of various sensors where it facilitates the easy movement of the vehicles and uh, avoids traffic and avoids a lot of failures and mitigations when it comes to roads. So that is one thing. And then second comes in decision making. So decision making is, if I were to give you an example, when a vehicle is moving in a trajectory and suddenly there is, a zigzag road. So how, as a fully automated unit as a vehicle, how will it make the decision of traversing through that complicated road path? So that is one thing. Then predictive modeling. So predictive modeling is when it has been trained to a certain set of environment of data of videos and of roads and different pavements and pathways.
Okay, so yeah, I'm going to have to remove somebody here. You are still on mute. You have gone back on mute. Mukul, I'm going to block you from this call. I'm sorry.
Who is someone muting me? Hello, is someone muting me?
It is some guy called Mukul, so I have removed him and blocked him from this call.
Great, great. Because I thought I was pressing something, but I don't think I pressed anything. Don't know why people do that. Anyways, can I continue?
Yes. Yeah.
Okay. All right.
So this gentleman was
Hello. So you were
let's
saying
go
something? So your voice is.
ahead.
Hello.
Go ahead. Go ahead.
Okay. So yeah, that is bit about predictive modeling, where the vehicle is able to predict certain outcomes of how it has to navigate towards its destination or towards any path that it would be taking in when moving in a certain direction or a trajectory. Then we have simulations and settings. So generative AI plays a huge role in creating simulations where you're able to create an virtual environment for the vehicle or for any sort of automobile to traverse through, where you're creating a virtual environment and then you're able to train the vehicle to traverse through that certain path and eventually deploy it as a model and feed it into the back end of say an ADAS system. An ADAS system is a huge example of a simulation that has come into fruition with using generative AI. So we'll talk about ADAS system in more detail in the upcoming slides. But as of now, this is something that you would have to know that generative AI plays a huge role in creating simulation. Then comes map generation. So generative AI, when in advanced cars, so there are 5 levels of automotive automobiles in the future, which I'll be talking about in the upcoming slides, where uh, it can generate its own map. It does not have it learns through iterations and through predictive modeling. It is able to generate its own map and it is able to traverse through a lot of destinations and typographies of areas. So that is something that is which is a futuristic vision of generative AI engineers to facilitate in the current automobile sector. And next we have robotic vehicles. So robotic vehicles, as the name suggests, means when robots are vehicles literally act like robots, where you prompt in, say I want to move to a certain destination to collect my food delivery, right? My food from a takeaway area. So it is able to perform that operation by just through prompting. So these are the futuristic outlooks of how generative AI can affect the automotive sector in vehicles. So is someone sending me a message? Yes, Paul has a question. Please do ask.
Yeah. Can you, if you don't mind, can you just repeat the last point, this map generation? Because of this audio problem and all, I lost the
Oh, okay,
concept.
okay, okay. Sure, sure, sure. Am I audible to you, Paul?
Yeah, yeah, you're audible.
Okay.
Some person actually, I don't know what he is doing.
Yeah, yeah. So basically, map generation is say like uh, in say I'm giving you an example where I'm moving from Chennai to Bangalore, and I do not have Google Maps, and I need to traverse through through the trajectory where I'm using my automotive vehicle. So with implementing with use the advanced levels of generative AI will facilitate will facilitate this process where it is creating its own path, and it is able to navigate you comfortably to that destination. So map generation is something where the vehicle intrinsically would realize that okay, this is the destination that the person needs to be dropped at, and it is able to create a map sort of picture for traversing. So it is able to navigate to that path, and also map
Really?
generation. Sorry.
Mhm. Sorry, sorry. Go ahead. Go ahead.
So this is a futuristic outlook, right? It is not yet come. I can show you some videos where it is able to create maps. I'll be explaining this in the upcoming slides. Is
Great.
there any is there any other questions, Paul?
Uh, uh, in simulation and setting, this setting part, maybe I missed also in the simulations.
Okay, so simulations and settings. Okay, so basically simulations and settings means like when you're controlling the vehicle in a certain when you're introducing the vehicle in a certain environment. Like there is this startup called Navia. So Navia has been working on creating self-driving cars, and they have realized that there is 5 levels of automation in self-driving cars with generative AI, which I'll be talking about in the upcoming slides. But in level 4, you will need very less human intervention. And Navia has realized that with the current technology that we have, we can create carpooling mechanisms with the existing cars that is out there with automation. So with the and especially in an urban setting where time, space, and size of the car matters a lot, because you have seen Tesla had launched uh, what is that, Cybertruck, right? Cybertruck is the closest that you can think of a level 4 or level 5 automotive car. But the reason why it flopped in the market was because of its huge size. And so Navya took this as a lesson, and it realized that it has to create a sophisticated engine where it is small in size, where the utility is also high. So Navya tapped into the market of self-driving cars in as a carpooling service. So they have been able to generate a lot of revenue by this is startup in San Francisco, and they have been generating a lot of revenue, and the utility is huge. So they have made full utilization of generative AI in in a certain environment. So they knew that Bay Area was populated and very traffic hours. So they realized that they could create a simulation software and implement it on self-driving cars. So simulation and settings are something that is a key feature that has come through generative AI. Is that understandable now?
Thank you.
With
Thank you. Thank
Yeah.
you. Yeah, that's quite wonderful to know all these use cases.
Yes, yes, definitely. So Navya is a startup. I was just researching about them. They're very impressive. They started like 5 years ago, and now they have fully automated almost level 5 self-driving cars that have been in the operational stage in the Bay Area, which have been doing cab services, basically cab services. So these are fully automated electric vehicles. So that's a huge huge testament to how generative AI has helped in the automotive sector. So
Well,
yeah, uh, next, we have use cases of generative AI in automotive sector. So use cases span up to all of these: navigation, supply chain, personal voice assistance, automotive manufacturing, quality control, and predictive maintenance. So how does automation or generative AI help in the supply chain of automotive sector? So, the automotive supply chain is a very complex network of suppliers, manufacturers, and service providers. And more often, all of these come work together to produce and distribute vehicles. So supply chain uh, has produced, like has created all of these, included all of these aspects such as raw materials. So like suppliers need mining and processing companies that provide raw materials. So and then we have component suppliers. So these suppliers create parts like engines and transmissions, which are sent to assembly plants. So all and then inside the assembly plant, we have the cars being assembled. So this I'm basically talking about the architecture of supply chain within an automotive industry. And then we have dealerships. So this comes to the sales part where cars are sold to customers or dealerships. And then the aftermarket of this. So after a car is sold, the aftermarket industry provides parts and accessories of that particular vehicle. And then recycling, because recycling is a huge aspect, and it has created a huge revenue in itself, where when a car reaches the end of its life cycle, it is recycled or disposed in a sustainable manner. So all of these can be automated through generative AI. So the whole supply chain network, if automated, would be this is the future that we can think of, where all of this, say through a SaaS platform or something, all of these multi all of these use cases can be brought together and automated through generative AI. So that is one use case. Then the second one is quality control. So quality control, so generative AI significantly enhances quality control in manufacturing by automating defect detection and analysis with high accuracy. So it is able to leverage machine learning algorithms to analyze real-time data and from production lines, thus identifying anomalies and deviations from quality standards that traditional methods might miss. So traditional methods, through traditional methods, it's you largely trial and error. But through generative AI, we are able to bypass that trial and error method, and we are able to efficiently bring about a certain defect detection or analysis with high accuracy through generative AI. And so by continuously learning from these historical data and patterns, generative AI can predict potential issues before they even occur. So it means that it's being precautious. It's able to know what is going to happen even before it has occurred. This is the future that we see with generative AI. And it's very exciting because then we can reduce a lot of these, traffic malfunctions that have been happening in roads, right? So it all comes down to quality control. If the quality control sector has been accurate enough to predict a certain fault in a certain vehicle, then we are able to bypass all of these potential threats that can come into picture when we are deploying a vehicle, a commercial vehicle in the road setting. So this proactive approach not only improves this productive consistency, but also reduces time and cost associated with manual inspection and rework. So generative AI is able to maintain that high standard, minimizing waste, and ensures that product meets or exceeds customer expectations. Then comes automotive manufacturing. So generative AI has played a huge role by optimizing design. As you can see in the picture, the automobile is being designed by a certain automated machine, right? So when generative AI is coming to play, you can think about engineers, creating innovative vehicle designs through advanced simulations. So through generative AI, so through prompt engineering, say I'm telling, can you change the chassis of a certain vehicle into a more streamlined and aerodynamic manner, so that say I'm designing a sports car and I want it to be more streamlined and aerodynamic so that it reduces the drag force, right? There's a concept called drag force where the less the drag force, the more it is able to navigate faster in roads for sports cars. So you're able to prompt this and you're able to create a simulation of this particular vehicle that you desire. So um, this is the future that you can see in automotive manufacturing. Then personal voice assistants. This comes as the internal features in a certain vehicle. So generative AI enhances personalized recommendations where by analyzing extensive data from customer interaction preferences and vehicle usage patterns, it is able to offer tailored vehicle features and services based on the individual's needs and preferences. So by leveraging such advanced algorithms, you are able to predict which options or which upgrades might be best suited for a certain certain person based on his personality. So it is able to adapt based on the driver's personality. That is the kind of thing that you can think with generative AI. Like even in our phones, like I'm giving phones as an example because Siri is able to respond. If you're an iPhone user, you're able to understand how Siri is able to adapt to your way of thinking, your way of usership and everything. So sooner or later you will see cars also behaving in that similar way, where it is able to understand how the driver is, what the personality of the driver is, and what is his likes and dislikes, and how is his personality in the road, and it is able to adapt based on that. So this is one of the main features of generative AI in the automotive sector. And then comes predictive maintenance. So in predictive maintenance, you are able to analyze vast amounts of vehicle sensors, historical maintenance records, and usage patterns to forecast potential issues even before they rise. So, so this is another thing. Like it is able to create a maintenance, mechanism where it is able to understand what can happen, what are the faults that can happen. Say in NASCARs, like NASCARs and F1 Formula One cars, the engineers, the manual engineers, have to change the tires. And you will see like after like 20 laps, when the car exhausts, it comes to the what do they call it, the mosh pit. It comes to the mosh pit, and then the test engineers run, and then they make a lot of changes within fractions of seconds, right? But say with generative AI, you're able to you're able to navigate comfortably where you don't need any human intervention. This can be as the generative AI learns all of these techniques, it is able to automatically perform all of these operations without human intervention, and even more accurately than humans. So it is saving up much time and cost and human manual labor. So that is one of the attractive features of generative AI in the automotive sector. Then we have navigation. So navigation, like what I said in the previous slide, we have map generation, right? So generative AI through various through intervention of through learning of various road maps and road architecture, it has come it will eventually come to a point where it is able to navigate you to any destination seamlessly without any hassle. So that is the future that you can think of with the advent of generative AI in the automotive sector. So all of these are the use cases of generative AI in the automotive sector, and I hope I have explained in thorough detail. Now, we will look at how generative AI is affecting the design for automotive parts. So, you can see in this slide, it's a very fascinating innovation that has come into picture with the advent of generative AI, where they have used a certain model called deep Bayesian optimization. So deep Bayesian optimization basically can morph this you see a simple looking car into an aerodynamically optimal shape that you can see on the right side. So basically what goes into picture is geometric deep learning. So geometric deep learning is something where you need not parameterize. So you don't have to pass in parameters, and it can create these aerodynamic paths for this say particular vehicle with by managing the raw materials. So now we have 3D printing as well, where we are able to 3D print certain parts, and through generative design we are able and using of this particular algorithm called deep Bayesian optimization, where so what goes into deep Bayesian optimization is a fascinating marvel with in mathematics, where it uses machine learning and Bayesian optimization concepts to explore different shapes and configurations, aiming to find the best possible design. So in simple terms, debosh is a method used to optimize the design of objects or systems like cars, drones, robots, to make them more efficient or better performing. It uses machine learning and Bayesian optimization to explore different and shapes and configurations. So Bayesian optimization, if I were to go deep into the algorithm, it is basically when you're a certain utility of a vehicle or certain part of a vehicle, it is basically looking into the design of the vehicle from each point or each coordinate in a 3D simulation software. So through deep Bayesian optimization, which is deep Bosch in short, we are able to create complex designs like parts of the cars, like the wiper of a car to make it more aerodynamic, the chassis of the car, the parts of the motor or the generator of a car. uh, you would have learned where in mechanical engineering in my bachelor's, I remember the more the spokes of a certain generator, and uh, the lesser the spokes of the generator and more the speed, it is able to the quicker the generator for the car, right? The number of turns, by the number of turns you're able to so you will see in fast cars, in like race cars, the spokes are minute, and so that it traverses through lesser area, and the speed is high. So such concepts are taken into picture when you're creating such designs for automotive parts using generative AI. And this drastically is an improvement from traditional AI patterns, because traditional AI patterns is very like it requires parameterization. There is cost for parameterization. So parameters here belongs to like the type of raw materials, the the type of spokes that you need, whether it is narrow, whether it is broad, whether it's rectangular, whether the spokes should be like circular, hexagonal, cylindrical. All of these when you're able to use geometric deep learning, it is able to accurately design that particular part for you based on the use case. So this is a huge intervention of generative design, where automotive parts have brought out hyper modifications, and it has changed the whole dynamics of the vehicle. So, so this is one of the use cases of generative AI design, right? Where through prompting, you're just able to design such complex parts of a vehicle and customize your vehicle. So yeah, this is one of the features. And now we are talking about, I'm going to talk about how it helps in vehicle development. So we are talking about how now we are getting into the concept of self-driving algorithms. So when we talk about self-driving cars, we see that we are training models using generative AI, uh, like, and we look into aspects like quality control and predictive maintenance, as I mentioned in the previous slide. And we are able to generate synthetic data for testing autonomous driving. And then it is also able to plan the path accurately and make decisions consequently, uh, using AI. So like this is what you can think of. So when you talk about synthetic data, I'd like to give you an example through the advent of a video, where a vehicle is able to correctly identify a certain object. So synthetic data basically means through simulation software, it is able to correctly identify a certain person, a certain vehicle, whatever are the roadblocks that are coming in a certain in a certain road architecture, like a tree or a cow moving. In India you have a lot of cows moving in the main roads, right? So all of this, through AI, if it's able to detect these synthetic data in the form of objects, then we are creating a simulation software where we are able to create a foolproof autonomous vehicle. So, and eventually create a path planning mechanism where it's able to make decisions seamlessly to navigate through every path when there are say roadblocks. So this is a huge advancement, and Nvidia has come up with a great innovation, and I would like to show you a certain video which is very inspirational in terms of optimizing AI models. I'd like to take your time so that you can watch this 3-minute video, and it talks about how Nvidia has created this system, this very complex architecture for a vehicle, where it is able to comfortably where it is able to detect many vehicles in a certain road, and in a highway, and all of these. And so it is able to optimize the experience of that self-driving car. And they use this particular method called HALP, which you can see in the, and it's a pruning technique. So pruning means like basically staving off a lot of unwanted features in your neural network, which goes into the self-driving car, so that you're able to arrive at a more precise answer on what the object is, or how to navigate to a certain path. All of these are basically through convolution, like through neural network architectures. So Nvidia has designed this particular architecture called HALP, which is able to navigate a certain vehicle through comfortably in a certain road. So through this video you will be able to understand, and I hope I can take some of your time to are you guys okay if I play this video?
I mean, you have a 1 hour webinar, right? So you can manage your time accordingly.
Yes, yes, yeah. So this is just a 3-minute video.
You have to share the audio.
Sorry,
Audio is not coming.
the audio is not coming. uh I don't understand. Is the audio
Yeah,
not coming?
yeah, in PPT it won't come. That's okay. You can move to next slide.
Okay, but anyways, if anyone wants this PowerPoint later on, I'll share it with you. It's a very interesting topic where okay, let me just show you images of this video presentation. Yeah, so basically this. So you have an input data which is um, like a trajectory, a road path, right? And this is the model search neural pattern. And then here it is able to you're performing light optimization. So light optimization is basically giving these neural patterns a certain utility to predict to be deployed in the vehicle in the future instances. So wait, sorry.
So, Mrinal, one question. In all
Yeah,
these use cases, right, where
yeah.
is GenAI coming into picture? Means which LLM was, or at least if you are aware, which LLM was used here?
So that's a good question. I actually researched about that, but most of these companies, they're like Nvidia and all of these, even Navia. When I researched about it, they have not revealed it out. They have not shown what LLM that they're using, because it's just not yet come to commercial markets. So they have not yet released it. So they're using as of now. I'm able to understand the behind the scenes is that they are using neural network architectures. So they have not. Yeah,
Okay, but is that still a GenAI model used? That's fine if it is not known which LLM, but is
yeah.
it still a generative AI model or a foundation model there?
Yes. So like, what would you think of as a model when you think about a generative AI model?
In this case, you see light optimization and so on, right?
Yeah,
It's as you
yeah,
said, there is a lot of pruning happening in the neural nets. So,
yeah.
where did generative AI come into picture to help this happen?
Uh, so like, um, I mean, I don't think necessarily it could be like generative AI. So generative AI is basically through prompt engineering, right? But like, I think these are the inner this is what happens inside the architecture of a generative AI model. So say you're using a GAN network, a variable autoencoder, and all of these. So all of these have neural patterns with inside the network, right? And if you're and it can, based on the utility case, utility, uh, the patterns or the neural network can be sophisticated, and so you'll have number of features that goes into planning, path planning, and everything. So in order to customize that, you're pruning a lot of features. So that's the use case that I can see with generative AI. I hope that answered the question. So you have like BERT architecture for a vehicle, vehicle simulation software. If you are creating a BERT architecture or a GAN architecture, so I'll be talking about that in the later slides, where all of these transformer models, when used, the use cases of these transformer models. So I think then you will have, I think your question will be answered at that time.
Okay, Got it. It need not be necessarily a LLM here, but it can be a transformer-based model, as you
Yes,
said.
yes, it can be a transformer-based model. It can, yeah. So there are like BERT architectures, there are GAN architectures, there are BAE architectures, and I'll be talking about that in the course of the upcoming slides. But
Okay.
yeah, so I just wanted you to see some snapshots of this, where you know, all of these unwanted. This is the basic hardware that goes into the. This is the microcontroller, right? And the microcontroller has various inputs, and within that, the certain input has certain within the huge micro controller, you have certain like certain features, that certain microprocessors, you would say, that perform certain operations. And so when you're customizing it for a certain thing, say lidar technique is basically through light you're able to detect a certain object which is in ahead of you or behind you, or have a 360 viewpoint. So we might need to only use the light capturing, so it's called motion capturing sensor, right? So in that microcontroller, if you're able to tap into the motion capturing sensor of that particular microcontroller, and if you're able to deploy that model and pu- uh, implemented inside the self-driving car, then it will only use that particular feature, which is motion capturing sensor of, or a lidar technique sensor. So based on a certain use case, you're able to prune a lot of. So the idea of this video is that you're able to prune based on certain use cases for peak performance, because when you're distributing it for multiple use cases, the efficiency reduces. So Nvidia, as a huge chip manufacturing firm, works on efficiency and consistency, and they have their R&D have looked into how they can bring about a change in the self-driving cars efficiency, because we have been hearing a lot of not all is rosy and nice about self-driving cars. There have been multiple road accidents as well, and so Nvidia has tapped into that problem, and they have created this concept of pruning AI models, where they can they can be implemented for peak performance. I hope that answered your question.
Sure. I think the approach here within the automobile industry is a bit different. Means not necessarily at the regular use of LLMs and even LSMs, or it need not necessarily be a language model at all. I think it's down to basics to start with transformers, I guess, right?
Yeah. It goes down to transformers, but even generative AI as such goes down to transformers, right? Like a BERT architecture is uh, a transformer was the advent of generative AI, right? What is that paper? All you need to know is something. Attention. Attention is all you need to have.
Attention.
Yeah, so all of that started with transformers. So generative AI, I mean, I'm a gen AI engineer, so I am calling it generative AI because the fundamentals of generative AI have also been brought into this picture, is what I'm trying to say. I won't necessarily say like, oh, through prompting you're able to do it. No, that's not what I meant. um, what I mean is these use cases, like these architectures of BERT or GAN or variable auto encoders, they can be implemented in vehicles also. So that is the point of this presentation, where I'm able to these generative AI use cases can also be used in automobiles, if that makes sense.
Sure.
Yeah.
In
Okay.
the Chakapura,
Sorry.
it's on.
Sorry.
Hmm. Sorry, please go.
Yeah. Okay. So excuse me. Um, so simulation and testing environments, right? So what kind of environment would you want to place your vehicle in or create what kind of environment would you train your generative AI model for a vehicle to function in its optimal state. So autonomous vehicle need to be tested in various ranges of driving conditions to ensure safety and performance. So uh, sorry. Yeah. So this is where AI-driven simulations come into play, where leveraging generative AI and advanced simulation tools, developers can replicate real-world algorithms and real-world driving scenarios, traffic patterns, and environmental conditions, offering a safe and scalable way to train self-driving systems. Um, sorry. Yeah. Yeah, so that is one use case. And then benefits of AI driven simulations over physical testing. So there are a number of benefits of having an AI driven simulation over physical testing. One of them is that it can be set in an urban or rural setting. So to bring in a more diverse pattern to the data set that you're going to train the model to, you will have to introduce it to a number of road systems, say it in an urban setting and in a rural setting. And a number of factors come into play, like and weather variability. So say the demography of a certain location is that it almost rains every day. How does the vehicle adapt in such a way that it is able to switch on the wiper of your windshield wiper of your car, so that whenever it's raining, it is able to preempt and start the windshield wiper, and the driver does not have to worry about it. So all of these are some of the features of how generative AI can play a huge role based on demography, based on weather conditions of a certain place. So it continuously learns as it travels, as the generative AI model, which is installed in a certain vehicle, as it travels through different demography, it is able to continuously learn about certain areas, and when it comes to a certain location, it is able to understand that the weather patterns of this place is so and so. So the beauty of it is it is able to adapt your vehicle to that certain to that certain environment that it is placed in. And then to evade dynamic obstacles. So while simulating unpredictable events, like say a pedestrian, like I said, like a cow, or passing the roads across a main road, or like a pedestrian stepping into a road, or someone asking for help. Autonomous cars can learn to respond safely from such situations. And then we have edge cases. So AI simulations allow testing of rare and dangerous scenarios. So say there is a deer running across a bunch of in the US. There have been a huge issue with in certain valleys in US. There have been huge issues with yaks just running past the roads during the late in night. So you can see a lot of yak yak road accidents, yak collisions with vehicles have killed a lot of uh, pedestrians, a lot of vehicle owners. So AI simulation can detect such edge cases where unpredictability can be a huge factor behind behind a certain person's safety, or which could cause hazard to a certain person's safety, or driver's safety. So edge cases play a huge role in that. So AI, these simulations and testing environments are aware of such edge cases, and it is able to create a holistic approach when it comes to navigating comfortably in a road setting. So another marvel that NVIDIA has come about with vehicle personalization. Like I said, one of the features of generative AI is vehicle personalization, and to adapt the based on the vehicle adapts based on the particular driver's personality, right? So so you can see how generative NVIDIA has worked on creating a personalized experience for their self-driving cars using generative AI. And so like you can see here, so yeah, you can see here, like there's an emoji here which greets the person while she or he is driving the car, and it is able to recognize the driver with like real understanding. So these are some of the features of. So this is behind the scenes, right? Uh, you have Yeah, so you have sensor data, you have driver instructions, you have the car manual and knowledge base, and all of these input features are used to train the model, and it is passed through an NVIDIA DGX cloud. So NVIDIA has a cloud platform where it stores all of this input information and trains the data, and it creates a multimodal foundational, like a multimodal foundational model is also introduced. And so and then like based on a person's personality, it is able to create an avatar, and this NVIDIA OVX is a, like, an ecosystem within the which is configured within the vehicle, where the uh, the user is having a seamless personalized experience where it is able to talk to you as, like, say, a co-passenger, and tell you when you're driving a car what are the hazards. It is able to create that personalized voice system. So this is how NVIDIA has come about creating a personalized voice system. I wish I could play this video to you because it's a very interesting video, and it shows how NVIDIA has created such a sophisticated software where it is acting literally like your assistant, and based on your personality and based on how you have previously navigated through roads, it is able to advise on how to better navigate roads and have a seamlessly better driving experience. So this is how NVIDIA works on has been working on such situations. I mean, such use cases. So you have control over the microphone, internal camera, and external camera. So internal camera being, say, within the car itself, you're able to, you're able to see what is going behind. What is your co-passengers doing? Are they safe co-passengers? And then external cameras, say, it will be very useful for parking assistance, where human intervention. Basically, you don't have to literally, like, look behind and park your car, whereas your envy this platform is able to create this seamlessly safe and efficient feature where you can park your car comfortably. So all of these are some of the features that the self-driving car has, NVIDIA has worked upon by creating the OVX platform. Yeah. So if you want to say, like, it even works in internal settings, like internal features of a car where you like a song and you want to keep playing, but you have to concentrate on the road. The But based on your the number of times you have played a certain song, the OVX is able to understand. NVIDIA OVX is able to understand that you have liked the song so much that you need the song to be played. So without you even asking, or without you even touching the radio button in your car, it is able to play the song for you. So you can concentrate more on roads. So all of these are some added features of the NVIDIA OVX. So yeah, I wish I could play the whole video for you because this is a very fascinating innovation by NVIDIA. But nevertheless, we are also in lack of time. So yeah, so now I'm going to talk about how Gen AI models, right? This is, I think this will answer your question, sir. Where Gen AI models, how when how what are the use cases and applications of these Gen AI models in automotive industries? So transformer models like BERT architecture, you have uh, like attention based architecture that excels at processing sequential data. So basically BERT architecture is what, a bidirectional transformer encoder decoder, right? I mean, it's an encoder decoder architecture, right? So the inputs are basically binary. So say you want your a specific use case that I can think of is like, say you want your lights, the headlights on for your car at a certain time of the day when you're driving the car. And you don't have to think of like switching on the headlights. It will basically through through like several inputs, say like a daylight sensor that can detect that can detect the intensity of sunlight in a certain during a certain moment of the day. It is able to understand that during sunset it has to switch on the lights on. So that's an so the daylight sensor would to this AI model, it will send a one, binary input saying that your headlight should be on. So this would prompt the AI model to switch on the headlights when the sensors sending a one across the AI model. So number of this is a more this is just one piece of it, but I can think of a number of uh, AI models that I mean number of sensors when attached to a certain and connected into a integrated system. It is able to find out which use case should be the best suited for at a certain scenario when the car is navigating at a certain location. So that is how transformer models in layman terms, but when brought to production use, you can see that transformer models play a huge fundamental plays a huge foundation when it comes to creating the state of the art performance. So this improves route optimization. Like I said, like map generation is one thing where it is able to generate a map based on previously traversed paths, right? So all of this it creates an enhanced route optimization uh, as it considers a lot of factors. So it's a seemingly complex system which is able to uh, create the best experience for you. And the beauty of it is that it has come out from a decoder encoder architecture where you're literally passing binary numbers 0 and 1 to activate a certain sensor or to deactivate a certain sensor at a certain specific moment in time. So I hope this is able to answer your question, where how generative AI is able to play an efficient role in the makings of a certain self-driving car. Is that answering your question?
Yes, I think.
Yeah.
I would want to see some more use cases, right? So
Yeah,
that we
I mean,
know.
I have see. So these use cases, all of these use cases, I have it in the form of a video. So if you're able to see the video, you'll be able to understand the use case. But sadly, I don't know why the audio is not coming for the video. So I'm not able to play the video. I have even like more great videos in the upcoming slides. So, but anyways,
Maybe in the chat you can share the link. We'll
yes,
watch.
I will share. Once once this seminar is over, webinar is over, I'll definitely share the link to the chat on the link on the chat. Yeah. Then we have variational autoencoders, VAEs, right? So basically, these variational autoencoders are basically used for image processing and video processing. So I'll be showing you a code demonstration in a couple of minutes where you can see how through a certain video and taking mainly three factors into which is perception, planning, and interaction. All of these factors, three factors, taking all of these three factors into picture, uh, we are able to create a seamlessly, foolproof mechanism where a car or a vehicle is able to navigate without any hassle in a certain road setting. So variational autoencoder is the architecture of a variational autoencoder helps in creating such a thing where it is able to learn compressed latent representation of an input data. So it is able to identify that if the car has previously traversed through a certain path previously, it is able to identify, oh, okay, this is that path where we had to take where there is a U-turn, or where there's a dead end. So it is able to, even before the driver can preempt it, it is able to tell the driver that you will have to take a U-turn, or you will have to go traverse to another part because it's a dead end. So it has been used for various type of data, including images, not just video images, but even 3D models. So by 3D models, I mean like so you heard of mocap sensors, right? Motion cap sensors. So it is able to, when we are training large amounts of data of a certain road setting environment, where you have a lot of training videos of say an accident that has happened because a certain yak passed through the road, or a certain animal passed through the road. All of these accidents happening because of a certain case scenario, right? So it is able to identify through mocap sensors, is able to identify the motion of a certain object in a certain road setting, and it is able to identify that particular object and alert the driver, telling him that the certain object is there. So if say there's a huge if you're traversing through a jungle like area, and there's a certain stampede happening from an elephant, it is able to identify 2 to 3 kilometers away behind by identifying that there's a huge stampede happening. And such use cases are predominantly because of the advent of variational autoencoders. So and even in supply chain anomalies, where sometimes there might be malfunctioning within the complex supply chain design, right? Like I said, like in supply chain, I talked about how um, what is that? We have an interplay of the raw materials being processed, components, suppliers, dealerships, assembly plants in the car manufacturing sector itself. It is able to, it is it is able to understand that there is a certain malfunction happening in the supply chain of a certain production of a car, and it is able to intimate the automotive engineers and let them know that there's a malfunctioning happening in the supply chain. So even in the production side of a certain
Mrinal,
vehicle.
just a time check. It was a 1 hour webinar. So how long we need more?
Okay, so fine, sorry. Yeah, I just have yeah, and then this is almost the end. I wanted to talk about the levels of okay, fine. So yeah, I'll give you this slide where you can learn about how GANs and variational autoencoders and transformer models play a huge role in the application of automotive industry. So let me just summarize this quickly for you, because we are short of time. So now I'm going to talk about the 5 levels of generative AI cars, right? So in the level 0 car, which you can think about is the classical vehicle, where you have you have it controlled entirely by human intervention, and there might be some level of assisted automation involved while supporting the driver. So in such cases, like it is they do not qualify as automation as such, but because the human is responsible for the navigation, and there's no much automation there. So that whatever we see in the current day road scenarios are cars at the level zero, at the stage of level zero in automation. Then we have level one driver assistance. There's a video of this as well, which I generated through prompt engineering. So like through prompting, I created this video where it is talking about how you're creating a driver assistance through level one architecture. Where level one means like your a single automated system for a driver assistance is incorporated into the vehicle's functionalities, which may include steering. Like say in this video you can see, you don't even need to this is level zero automation, but in level one it is able to steer comfortably for a certain driver. So automation is ADD, so adaptive cruise control, is one primary use case of level one driver assistance, where cruise control is when you want to set a certain speed in a car when you're traversing through a certain when you're navigating through a certain pathway in the road, right? Say you're in a highway and it is okay to go at 120 kilometers per hour because you need to reach your destination as soon as possible. So through adaptive cruise control, you're able to set the parameter, or the what do they call it, the todometer, right? The todometer to the speedometer, sorry, the speedometer to 120 kilometers per hour, and it will be static at 120 kilometer per hour for the entirety of the highway. So that is one use case that you can think, where the automation of acceleration without human pressing the accelerator with his feet, he's able to navigate comfortably using the driving using the level one of automation of adaptive cruise control. So that is one use case that I can think of with level one. Okay, so level two is partial driving automation. So in level two, you have both steering and accelerating. So previously it was just acceleration, but in level two you have both steering and acceleration. So something that comes in a feature that has been widely successful in the automation industry is the ADAS feature, which is Advanced Driver Assistance System, where it is enabling the vehicle to handle both steering and accelerating, right, and decelerating also. So it's a fully fledged system where a human driver is able to sit in the driver's seat and take control of the car at any moment. So one example of level two includes the Tesla's autopilot, right? And the Cadillac Super Cruise Control, where it enhances the experience for the driver, where where the driver does not even need to lay his hands on the steering wheel. He just has to like sit, and he does not need to place his feet as well. So this sort of automation is possible through an ADAS control. So that is level two of automation. I'm sorry, I'm pressed for time, so I'm going fast. But level three is conditional driving automation, where you can see in this picture where the driver is literally facing the co-passenger, and he can excuse me, he can interact with the co-passenger while the car is running. So right, so level three automation is kind of futuristic because it has not come into production level yet, where you seldom see the driver facing the co-passenger. I don't think cars have come into this level of automation yet. But what goes behind the level three automation architecture is that it is able to detect environments. So based on, say, you're in a highway, and the highway is 120 kilometers ahead, and it is boring to sit in front of the steering vehicle and then just wait for 2 hours to finish the highway, right? So what if you had a system where you can just interact with your co-passengers, even like play games, or have a great, maybe even in fact, even increasing your level of happiness while driving, right? Because you're interacting with people around you. So when you're creating such interactive, to create such interactive experience, level 3 automation is is a dynamic driving system where you need not need any sort of human surveillance, and the car navigates comfortably through that path. And it uses techniques like eye tracking and facial recognition to ensure like clear and timely communication between the vehicle and the driver. So when the driver has reached a certain destination, the city where the roads are narrower, then the level 3 automation would tell the driver that we will need your intervention in this case, because we are traversing through high traffic area. So the switch that happens between comfortable navigation without human intervention and with human intervention is something that we can see in level 3 self-driving cars. And then level 4. Level 4 is basically driverless. So you don't even need a driver, right? Basically, you can sit at the rear at the rear seat, and you can just probably go about your day. You can even sleep while the car is taking you to your destination. So in order to reach the level 4 automobile automation experience, there must be a real-time map creation. So basically, as the car is moving through a certain environment, and it is learning from that environment through creating maps. So like I said, map generation in real time is uh, is the use case that you can think of, where through every split second it is adapting and learning and adding to its memory a certain environment that it is being traversing. So in that case, you don't even need a driver, and it is able to adapt within through milliseconds, that it is able to adapt to what needs to be done at a certain scenario. So this is the kind of high driving automation experience that you would be wanting to think of in the upcoming future, and this is how generative AI can play a huge role. Now, level 5 is full driving automation, right? So in level 5, vehicles transcend the need for human attention. As you don't need dynamic driving itself. Like they break free from geofencing. So basically, geofencing is a concept. Let me tell you. One second. Yeah, so geofencing is a concept where you can think of. So geofencing is like this, where when a certain vehicle is in a certain environment, uh, through other sources, it is able to understand that that particular vehicle is in a certain environment. So a perfect example of geofencing, this is outside vehicles, but could be this app called Snapchat, where it is able to understand where a particular user is at a given time in a certain location in the world. So you can see the Snapchat map, and you can know where your friends are at. So geofencing, if it is implemented in vehicles, it can understand where a certain, say you want to meet a friend who's also just like 50 kilometers away, but you didn't know that, but you said you want to make him a surprise visit. So say he's just 50 kilometers ahead, but if you accelerate like 140 kilometers per hour in a safe environment, through geofencing technique and through full driving automation, it is able to you're able to meet your friend who is in the same highway as you, but only who's on 60 kilometers ahead. So such cool concepts can be thought of through full driving automation and through concepts like geofencing, where it can go anywhere and perform any driving task, just like experienced human drivers. So companies have been working on this extensively, like Audi and BMW have been working on this, and has not stopped with auto Copilot. They have been wanting. So Cybertruck is an innovation in the level 3 stage of self-driving cars. but Elon Musk has been having talks of how to create a fully automated system where you don't even need a driver. So level 5 has been in talks, and that's what we can think about in the upcoming future. So this is a video that I had created, but I don't think the audio will. So yeah, I can share you the slides in the chat, and you can have a look at the video because it's really fascinating. So the benefits of generative AI in automotive space, right? There are a number of benefits in the of generative AI which I can think of, and one thing is enhanced design. So the design engineers for automobiles do not have to go through the cumbersome method of trial and error, and rather create a seamlessly hassle-free design experience where through models that I mentioned previously, like Deep Bosch, right? So Deep Bosch, which uses Bayesian optimization technique, we are the engineers, the design vehicle design engineers are able to create a foolproof model for a vehicle. So for a vehicle's architecture based on its use case. So this is something that through generative AI, I think can bring about a huge difference in what to say in the automotive space. Then what I can think of is optimized manufacturing processes. So like supply chain. In supply chain, when it is largely human driven at this point, but through generative AI, if you are able to bring about you know like better concepts like you're able to build an architecture where you're able to create better resource utilization, reduce waste, and increase production efficiency, then AI-driven predictive maintenance also helps in minimizing downtime by anticipating equipment failures. So it's being precautious about the equipment failures even before they occur. So that is one benefit that I can think of. Then improved quality control. So generative AI enhances quality control, as I mentioned previously, as it ensures that any anomalies are quickly addressed, maintains high quality standards, and reduces the rate of defective products reaching the market. Then we have enhanced autonomous vehicle safety. So plays a huge role in development of autonomous vehicles. This plays a huge role by processing and learning from vast amounts of say data collected from various sensors, like I said previously, like mocap sensor or a lidar sensor. You're able to improve the decision making process for a car to comfortably navigate through a road trajectory, and this enhances safety and reliability for the passenger or the driver on the self-driving car. Then another great use case that I have not talked about was enhanced after-sales service. So this can also enhance, the sales experience of a certain self-driving car, where uh, where generative AI can predict when a vehicle is likely to need maintenance. So these days, we are manually anticipating our maintenance based on our car insurance, right? But say in by feeding in the information of your car to generative AI model, it is able to forecast when you actually need your car servicing to be done. So in that way, you don't have to take an anticipatory bail on when you have to go through your car service. So this improves the sales services, after sales services. So and even creates a good reputation for the car, because we all know, let's face it, like we don't want much of car servicing to happen for our vehicle, right? Like it undermines the credibility of the car manufacturing if you have to go through a lot of servicing. So if AI is able to predict when you're requiring car maintenance, then it improves the after sales services as well. And creating a robust vehicle customization platform. So Generative AI allows for diverse customization for customers, enabling them to configure their vehicles to their exact preferences. This can include like personalized design elements, performance settings, or or an in-car feature technology like your stereo, your your rear view mirror, or your windshield wiper, and all of these things. So, and then predictive analytics for market trends. So so this is for future for purposes, where you can think of generative AI playing a huge role in analyzing the vast amounts of market data to predict future trends and consumer demands. So this allows automotive companies to stay ahead of the curve and adjust their strategies accordingly. So generative AI its ability to analyze vast amounts of data and provide actionable insights makes it a transformative tool in automotive industry, driving efficiency, innovation, and customer satisfaction across the board. I would like to show you a code, but I don't think I have the time. I can share you the code in the advent of the chat. Will that be okay? Hello? Are you there, guys? Are you there, guys?
Yeah.
Will that be okay? Should you want me to demonstrate it? Because I don't have time. I think Vivek sir is also telling me to wrap it up. Sir, can I show the code?
Just show it very fast. Don't belabor on it long.
Okay. So basically, I created a self-driving simulation, right? So I can't I don't have the output because I'm not in the road right now. But this is an example. So say I'm loading an MP4 of a video, like I'm capturing a video, right? And I'm capturing it by each frame. So this I'm importing CV2 because CV2 has this function called video capture. So this what goes behind the scenes. So I'm passing in a recorded video of a certain like road trajectory, and I'm processing each frame. So so what goes about here is so like you can see here that I have so this is a real time. So when this while loop is meaning that when I'm setting a camera or something on my car in real time, it is able to capture the video. And so you have a wait key here. So wait key is basically 25. So I passed 25 milliseconds. So this 25 milliseconds are the delay that is created for each frame. So so a video how a video capture works is like it goes frame by frame, but I'm creating a delay here because I want to capture each and every aspect of that road experience, right? And if I'm not creating a delay, then everything will go really fast. 25 milliseconds you would think is fast, but in terms of like video capturing, it is actually slow. So what I'm doing here is I'm creating an AND operation with 0xFF. So 0xFF is the bit size number for 255. So basically it is 8 ones, right? So when you're doing an AND operation across 8 ones, and I'm pressing Q. See, I'm sitting in a car. This is a scenario. I'm sitting in a car. I have a video camera on top of my the roof of my car, and I'm connecting it through wires on my USB port while sitting inside the car using a laptop. And now I'm pressing Q. So Q is basically to stop the video capture. So when Q is pressed, the AND operation is retains the value, and Q's ASCII value of Q is 113. So that value is captured and the video is captured. So this is what happens when I want to start a video and stop a video. So this is the code for that. And now I'm pre-processing the image. So this is so for pre-processing, I'm using resizing function, and I'm normalizing the function by dividing the pixel length by 255, and then I'm returning the numpy array of the normalized image. Now I have a processed image, right? Now I'm calling Keras model, and I'm importing sequential. These are a lot of convolution. These are convolution neural networks that I'm creating for tensors that I'm going to pass while I'm inputting each frame of this video, right? So I'm calling in convolution 2D, max pooling 2D, flatten and dense. So flatten would flatten the pixel values to 0, and dense would concentrate the so dense function would basically come into capturing a certain object or object detection, where it needs to at a certain frame of at a certain circumference of a frame width, you're able to understand that this object is a vehicle that is ahead of me, or a cow ahead of me, or whatever. So it is so through dense function you're able to create that within the neural network architecture. So I'm flattening it, and I'm using an optimizer called Adam optimizer, and passing in a cross entropy loss called binary cross entropy. And the only metrics that I'm using here is accuracy, because that is what is required while I'm capturing this, right? And now I'm loading a pre-trained model. Uh, so mobile net v2 is already present. It is basically a video of previously recorded videos. And now I'm loading that model, which contains the previously recorded videos of lot of road trajectories and things like that. And the input shape is 224 cross 3, and I'm adding a customized layer. So this is where I'm using my layer, the layer that I've created with my base model, which I've called here. I'm creating that layer here, and I'm calling it within this function, right? And now I'm calling the input base model, and I'm creating the output. So I'm creating a customized layer. So in other sense, I'm creating a transfer learning sort of platform, where I'm adding a custom layer to already pre-existing layer. And then so I'm using these so for self-driving simulation environment, you need to think about three things. Okay, perception, planning, and control. So perception thinks about the lane boundaries, the detected objects, like I said, car or pedestrian or something like that. So all of these are mapped in coordinates. So 100, 200 are the sizes, right? 200, 250 are the sizes of lane boundaries, or the coordinates at which the lane boundaries would occur. And pedestrian, this is the coordinates at which the car or a certain object detected would be within the video, right? So this is the BB box is basically the width at which the you will within the frame that you would find a certain car or a pedestrian. So you're creating that, and then say again, traffic sign. When you're creating a stop sign, so you need to prompt the car to stop. So for that, based on the traffic sign signal on the certain at the frame of the video, you're able to understand that this is a particular traffic sign, so you need to stop the car. So that is part of perception. And then planning is like I said, when the car has to when the car has been pre-trained to this existing model where I have performed transfer learning at, it is able to predict future paths, right? And it is able to come to a decision where, say, if there's a roadblock, it has to stop. Or say if the traffic turns red, traffic signal turns red, it uses perceptions input, and then plans on creating a decision to tell the car, intimate the car to stop. And then control belongs to the steering, largely on the steering and the you can think of an ADAS system where you're accelerating, and it is bringing in aspect the effect on the rear and the tires, the forward tires and the rear tires, and also your steering wheel. So all of these, the throttle, brake, and the steering angle comes into the picture when we think about control. So keeping in these three parameters, we are able to create a holistic self-driving car experience, hassle-free. So this is what happens behind the scenes of a self-driving car scenario. And now this would be the possible output. And like now I'm simulating the self-driving scenario, and for certain range I'm creating so this is basically a reinforcement learning model, where an input is passed, and feedback is so reinforcement learning, as you all know, is like when an input is passed and you're getting an output based on you're creating a reward system each time you're able to predict the correct input. Correct observation, right? So we are, through reinforcement learning, we are creating a seamlessly a great driving experience through a self-driving scenario. That is what I had to show about the code. I am sorry if I was a little, I'm pressed for time, so that's why I would have probably run through it a little faster. I wish I had more time to explain it in further detail, but please feel free to reach out to me on LinkedIn, on any other platform, if you want if you want the access to the code or any sort of other external additional information. So yeah, conclusion is that the evolution of generative AI has promised to reshape the automotive industry, which has created a new era of innovative possibilities and sustainable advancement. As these technologies continue to evolve, collaboration between AI developers, automotive manufacturers, and policymakers will be really vital to ensure responsible and inclusive integration for the uh, benefit of society. So that's all I have for today's webinar session. I'm sorry I took a lot of time, but I hope this is very informative and engaging to all of you. And feel free to ask any questions if you have, and if there is any additional research that I would have to do from my end for such questions, I'm more than happy to do. Yeah, thank you very much for your time.
Yeah, one quick question actually.
Yeah, tell me.
Regarding this code, actually, and the last part,
Yeah,
where this your automated map generation is happening, I believe.
yeah.
So the data set I can see very less. I think in practical scenario, this dictionary or the part in the last you go down, this particular dictionary set, this set will be very large, I believe.
Yes, yes,
Because there
yes,
will be a
definitely.
lot of vehicles and lot of trees and so many things.
Definitely,
Suppose.
definitely. But it all, so that's the thing here, sir. So three things are taken into consideration when you are basically creating a self-driving experience. It's perception, planning, and control. So you said, yeah, like rightfully you said, trees and all of that. So say trees. Here you have just what, cars, pedestrian, and traffic sign. You can add trees also. You can add trees into that dictionary, right? You can add in planning, you can add decision to start, decision to accelerate, decision to switch on your rear view, the headlights, the rear lights, the hazard meter. All of these, the more sophisticated a car becomes, the more you can add into these the dictionary key value pairs.
Right,
So
right.
but the basic thing that goes into this is perception, planning, and control, because these three are the fundamentals that creates that self-driving experience. Hope that makes sense.
Yeah, right. And
Yeah.
especially if for Indian good roads, if I have to add, we have to add cows and animals also, I believe.
Yes, yes, definitely, definitely. Yeah. So, any more questions, guys?
I think one more, if you go to
Yeah.
the level 4 slide,
Okay.
uh, and the level 4 side also, I think I wanted to ask something there. It's about map creation only. Yeah, this one.
Yeah.
Yeah, I'm bit little bit. I don't know. This is anything, any futuristic ideas and all. Obviously, we have to see from different angles. So here I am little bit skeptical right now. Maybe future
Mhm.
it will be automatically. Everything will be clear more.
Yeah.
So in this case, I am not sure. See, ma'am, without without any pre-mapped data itself on the fly, it will generate the on the road. It will automatically generate the map and go ahead,
Mm.
it can generate, it can generate, it's not impossible, but the thing is the effectiveness or the there's so many factors are there. I mean, say automatically you are generating the map through satellite data at the time, real
Yes.
time data.
Yeah.
And you can add on top of that, you can add the traffic data also.
Yes.
But still I'm not sure about, maybe in American roadways it is possible, but I'm a bit skeptical. It is really how much practical it will be on the road, depending on without any pre-map data in the vehicle, and you are generating those things. So
Yeah.
and the
So
title here, I think it should be high automation driving instead of high driving automation. I'm not sure,
okay.
but high
Okay.
automation driving.
Maybe maybe you're right about that. But like say I mentioned about this thing called geofencing, right? So
Yeah, geofencing, right?
yeah.
Geofencing, right,
So
right. Level 5.
geofencing is something that you can think of when you think of level 4 self-driving cars, because like you said, rightfully said, like it uses satellites, and through now you have geo. Have you used GeoMaps API? You can call it through. It's an API that you can call, and you can literally map any coordinates around the globe using GeoMaps. So
Right.
basically,
API
it
is it.
uses information from uh, you've heard of this application called Google Earth. Now it's not that prominent, but back in 2005,
Yeah. No, I like that app. Very, very nice app. Google Earth. Google Earth, you're saying, right? Hello. Are you saying Google Earth? Hello.